Hi there, so we're going to have a look at some more Hess's law questions. We should have done a few of these as part of the thing last time, but we're going to go for some more ones where we're doing manipulation of these equations. They can be quite hard, but if you just follow the process, then they should be quite simple to do. So we've got this one here where it's asking us to calculate the enthalpy change using these enthalpies of combustion that are given to us. One thing I'm going to say to you as well, and I'll probably be mentioning as we go along, when you're doing the enthalpies of combustion, notice it's always 1 mole of the substance being burned. I think we'll come on to one where it's hydrogen, and I'm just going to remind you of that because it looks a wee bit unusual, but once you understand it, it's fine. Okay, so this is the same question, just where I've got space to write. So obviously if we look at this, we're going to call this our target equation, because we want our equation that we make to be that. If we look at this, you can see it's a wee bit confusing, but we see some things that are in the right place. The CO2 is in the correct place. So I don't actually have to do anything to this equation because it's in the right proportions. It's got CO2, it's got 1 mole of each, and it's in the right place. This is in the right place, but notice there's a 2 here. So this means this equation is going to be times by 2. And notice that that's also going to cause that to become times by 2. Lastly, we've got this CS2, which we like, but it's in the wrong place. So we need to flip this one. It's in the right number moles though, so we'll reverse this. I'll just put a wee REV with a dot, which means reverse. Okay, so let's rewrite our equations. We'll reverse that. Let's rewrite our equations so we can do this. So we have C S. I'm just writing this first equation just the way it appears because we don't have to do anything to it. I'm going to times everything here by 2 in the second equation, so that's nice there for us. Just put the state symbols in. And then I'm going to reverse this last one as well. So I'm going to put CS2 for liquid going to CS plus 2S. Okay, and what I can do now is I can start to look at cancelling things out to then make my target equation from this. Remember, if you've got something that's the same on both sides, then that means you can cancel it out. So I'm going to start with my carbon. See, I've got a carbon on both sides that can be easily cancelled out. I've got a sulfur that can be cancelled out. Just noticing I wrote that wrong, that'd be an SO2, not a CO2. And that is us, we've got our final equation. So it's going to be CS2 those add together to make 3 oxygens, which is in the target equation, and then that makes CO2 plus 2SO2. And there we go, that's our target equation, which means we can work with these equations to work out the enthalpy change. So let's go to this. Our enthalpy change then is going to be minus 395, 3.5, sorry, and then it's going to be 296.8 times 2, which gives us 593, and then it's going to be, because that was plus 87.9, it's going to become minus 87.9. Oops. So in total, our energy change is minus 1074.4 kilojoules per mole. because we were using these out of enthalpies. And that is how we do these kind of questions. Okay, so it's just about looking at the equation, seeing how they're different or if they're similar from the target equation, making them so that they would be similar to the target equation, and then you look to cancel out the things that you've got on both sides once you've done that, and then once you've got that target equation that's the same, then you can use that to work out the enthalpy change, and that's how you do it. Okay, let's try another one. This is the same one, I've just skipped so I've got some space to write. I'm going to look at this, and this is what I was mentioning earlier. When I mentioned this H2 plus half O2, it's because it's 1 mole of hydrogen that's been burned, and obviously to have it turn into water, H2O, it needs to be half a mole of oxygen that it reacts with. So that's the only thing that looks a wee bit confusing with this, but it's just the same as what we've been doing before. So if we look at this, let's look at our target equations. So we've got calcium here, which is on the right side, that looks good. We've got calcium hydroxide and everything, that looks good. The only thing is, we've got this H2O here, don't we? But this is in the equation here, in the wrong way. Okay, so we need to fix that. What we're going to do is we need to, first off, let's start with this equation 1. In the target equation, it's got 2 waters, but this has only got 1, so we have to times this by 2, but also notice that that water's on the wrong side, so we're going to have to reverse that as well. So we're going to have to times 2 and reverse it. And remember, that changes the sign for the enthalpy. This one, calcium, is on the right side, so we don't actually have to do anything to this, so that's okay. Let's write out these equations again to try and fix this. So obviously, reversing this first equation is going to be 2H2O, and that gives us H2 plus O2. And then remember, that's not 2O2, because you've got half O2 times by 2 is just 1 O2. That's fine. Next one is just the same as what's there. CAS. Oops. It's a very big plus. Okay. And now let's look at places where we can actually look at cancelling things out. So, if we look at this, we can cancel out, bearing in mind that's a big plus, we can cancel out one of those H2s, and we can cancel out these O2s, which means that we've got our target equation. We've got CAS plus H2O, and that's 2, going to CaOH2 plus the H2. So that is correct. So we've done it right, we've got the right thing. That's good. So what we need to do is, let's work out our enthalpy now. We'll do that at the bottom where we've got some space. So if we look at this, our enthalpy for the combustion of hydrogen, we said we're timesing that by 2 and reversing it. So that's going to be plus 286 times 2. And that becomes 986. Nope, that's wrong. That becomes 572. For the second one, this enthalpy, 986, doesn't change. Oops. So that's going to be 986. So our enthalpy change then is going to be 572, take away 986, because that was exothermic, it's negative, so that becomes, we've got an energy change, enthalpy change, minus 414 kilojoules per mole. That's it. It's the final answer. So minus 414 kilojoules per mole. That's how we do these. I'm going to show you one last one that's a wee bit more difficult. So sometimes you might not be given the equations to use. So you won't actually have to work out the enthalpy of combustion reactions yourself. And this is easy because you just have to write a balanced equation for the reaction with oxygen. So we're going to do a practice and I'm going to show you how you do this. Now what you do need to know is that when you're finding these enthalpies, they're not giving you the actual enthalpy change. So you need to look it up and you'll look to page 10. Remember we said that's where you find the enthalpies in combustion. So enthalpies of combustion, page 10. So those are the numbers you need. And remember, don't accidentally go for the enthalpies of formation. You want the enthalpies of combustion, which are on the right hand side of the top of that table on page 10. Okay, let's do a wee practice. So we are going to go for it using these ones. Okay, so this is our target equation. And we are going to write out the equations as we go. So we're going to start with carbon. And the equation for carbon is C plus O2 gives us CO2. And that enthalpy change, if you go to the data booklet, is minus 394. The other one for hydrogen is going to be H2 plus a half O2 gives us H2O. Remember your state symbols as well. And that enthalpy change is minus 286. Now the last one is going to be slightly more harder. You're going to do this. So we can obviously do the oxygen one here because the enthalpy of combustion is oxygen is when you burn something with oxygen, so you can't burn it with itself. So that you don't actually have an enthalpy of combustion of oxygen. But we can do ethanol, which is this one here. That'd be C2H5OH plus O2, and then you want to make a balanced equation. Remember, when a hydrocarbon burns, it always produces carbon dioxide plus water. If you look at it here, you've got 2 carbons here, so that's going to be 2 CO2, so that balances out. And you have 1, 2, 3, 4, 5, 6. So you have 3 H2Os there. Now, if you look at these oxygens, you've got 1, 2, 3, 4 here, because you've got 2, and then you've got the big 2 in front of there, which means you times everything by 2. So that's 4 oxygens here, and you have 3 here, which means you've got 7 on that side in total. You've got 1 here, so we're going to make this a 3. And that means we've got 1 here, and then 6 here. That balances out. Good. That enthalpy change from the data booklet from page 10 is minus 1367. Right. Now we need to look at these equations that we've written out and made, and it's just the same step as what we were doing before. We need to look at the target equation and see how we can make these fit. So I'm going to start with the carbons. I can see that my carbon equation, my first equation, I've only got 1 mole of carbon, whereas in the target I've got 2, so I'm going to have to times this by 2. For the hydrogens, I've got 3 moles, so I'm going to have to times that by 3, the equation 2. And then if I look at the last one, I've got 1 mole of ethanol and 1 mole of ethanol in the target equation, that's correct. However, it's the wrong way round, so I'm going to reverse it. Now I'm going to try and write these out again, and obviously with my new numbers. So this is going to be 2C, oops, 2O2, and then it's going to be 3H2, and that makes 1.5O2. then we're reversing that around. There's 2CO2 plus 3H2O gives us C2H5OH plus 3O2. Now we can cancel everything out that we can. We've got 2CO2 there, 2CO2 there, 3H2O there, 3H2O there. In total we've got 3.5 oxygens here, but 3 down here, which means we can cancel out 3 of those, but we are still left with 0.5 O2, which means we've got our target equation. C2C plus 3H2 plus half O2 gives us C2H5OH. That's the target equation there. So we've got that good. Now we just need to work out the enthalpy change. We'll do that by doing times 2 times 3 and then reverse. So that works out to be minus 394 times 3, that is going to, or times 2 is going to be minus 788. 286 times 3 is going to be minus 858. And then that's just going to be plus 1367. So in total, the total enthalpy change is going to be minus 279 kilojoules per mole. And you can double underline that because that's your answer. Okay. Hopefully that makes sense. It's not too much more difficult, it's just the fact you've got to write out the equations yourself, and that might be a sticking point for some people. So if you're getting stuck with that, then I suggest you maybe go back and look at some National 5 stuff about making equations and balancing them. Okay.